Okay, welcome back. Today we'll be representing sinusoidal functions, rewriting equations in the form shown here from information given to us, whether it's in graphical form, the first example I do, or later on in kind of a wordy form. Part of our job will be to figure out what we're being told from the given information and how it helps us establish A, K, D, and C. At the end, we want those things to be filled in with numeric values. So sort of as we go through, given the graph below, find an equation, and kind of want to stress an equation. If you just sort of look at the graph that's below, you can see that this point, and really, I suppose all of these points are essentially the same point because the graph just continues on repeating itself. And so if in the original graph you figure that that point or something in this neighborhood was where that maximum value had been, it has now been shifted to the right a certain amount, to the left a certain amount, or theoretically to the right even further, to the left even further. And so all of those different values as far as the shift goes, specifically that value right there, are possibilities. Okay, so just sort of recognize that the answer you see in the back of the textbook may not match the answer you give. If you're not sure if your answer is the same, plug it into a graphing calculator or into Desmos and verify that your graph looks exactly the same as the one that they've given. If they do, then for sure they're both right. So when I look at this, I see a sign and so on. Again, probably working left to right, not for any reason other than it's fairly straightforward. My amplitude, by definition, is the distance from sort of the middle of my curve up and down. And so if I can establish where the middle of the curve is, I can simply count up or count down. It looks pretty clear here that the middle of the curve is right there at +1. The maximum values are up here at +3. And so my amplitude is 2. If I can't see that clearly from a graph, another possibility, of course, is that if I know where the maximum value is, again, +3 in this case, and I know where the minimum value is down here at -1, the amplitude will be half of that, half of the distance between. So the distance between two values is the subtraction of those two values divided by 2, because I want only half of it to be the amplitude, and again, +2. And you can just sort of count it out, right? From 3 down to -1 is a distance of 4. Halfway then is the distance of 2. So somehow there, kind of a couple of different perspectives on how to get the amplitude, but something there is going to get me the amplitude I need. Now I'm going to slide that down. Okay, so second value now, the K value. My K value helps me establish, or in this case, what I see on the graph is going to help me establish my K value. The K value comes from the period. The equation, we want to get kind of technical here. The period is exactly 360 divided by K. So the pure math of it is this. But what we recognize is by definition the period is the length of one cycle. So basically from my graph, where I basically start and then repeat. So actually use the same 2 points that we were kind of pointing out before. Right here to right here, that distance is one full period length. I'm going from wherever that is over to here, or maybe a slightly nicer one is from that point right there to that point right there. And although it doesn't really seem like that's what my intention was. The graph, again, would be slightly better if I recognize that that's exactly 180 degrees. So the period is 180 in this case. And so what that means is my K value can be calculated this way. Rearrange this equation and we find that K is 2. The alternative here, of course, is to remember that K is the actual number of cycles in 360 degrees. That's what this equation right here is telling me. It's saying my 360 degrees is divided by a certain number of full cycles. And so thinking through it backwards, to get from, if I looked at this in terms of from here all the way back, what do I cover in 360 degrees? Well, again, 1, 2 perfect cycles. Okay, so sort of a few different options there as well, just recognizing that that's what the 2 means, and that's how it relates to period. And then my other 2 values basically we're saying how far over and how far up have I shifted. Well, if my maximum value is 3, and my amplitude is 2, that means that on my original curve, I would have gone up to 2 and down to -2. But now I'm going up to 3 and down to -1 instead, which means that my C value is +1. My whole graph has gone up 1 more spot. So really, again, what we're doing is kind of mathematically thinking through what we know and what we're seeing on the graph. Again, what we'll be reading in the later questions. And finally, I'm looking at the last part, part D, probably the toughest part. I don't know if I'm going to squeeze this in here or not. If I think about where my graph would have been, in a typical sine curve, my graph would have started here and kind of gone up and then back down and so on. So when I look at the original curve, an original curve that goes through the 180 degrees, this would be my, I guess I should do it. Okay. So let's say that would have been my original sine curve before the left-right shift. This is 180, this is 90. So then halfway between those values would be 45. And now that 45 has gone from there over to this point here, halfway between 90 and 180, which is 135. And so my whole graph has shifted that direction 90 degrees. And so if I'm shifting to the right 90 degrees, that means D, again, sort of the opposite value, negative in this case, 90. So, kind of ran out of room here, but basically my final equation my A value we suggested was 2. The K value we found to be 2 as well. Just coincidence there, of course. I've shifted 90 degrees and I've shifted up 1. Okay, so now the only other possibility here, again, the last value, the D value could have been changed by having me think about, by having me consider that this value has in fact moved back to that value. And so I could have considered that D has a left shift of that same 90, or as I said before, I could theoretically have thought about it as I've actually shifted this far, which would be what, 45, 90, 270. So I've shifted the 90 and then another 180 over as well. So D being negative 90. In this case, D could be positive 90. That same number would only occur with the 90 specifically. If I had had a shift of 45 one direction, it might have been a shift of 135 another direction. So it's just the fact that the two 90s happen to make up the full 180 degree period in this case. So don't sort of just assume that either number is fine here. It just happens to be the case for this one example. So I could have shifted 90. I could also, again, shift 270 and so on. So there's sort of a variety of options there. The most logical one will always be to just go with the shortest shift. If I started in that same spot, I went that distance in that direction. Often there will be sort of, again, it won't necessarily be exactly halfway between the two maximums in this case, or the zeros if you want to work with the zeros. So take the most obvious of the various answers. So just some important terminology here now. What are you going to see? Okay, much like a word problem, the wording could be different depending on where you're pulling the question from, and you need to sort of interpret a little bit of what's there. Period, we know they sort of saw the formula there. Period is 60 degrees. So I was going to do an example. We already kind of did one. Basically 60 is going to be equal to 360 divided by k. And if we rearrange this, it's 60k equals 360. Okay, so it's divided on this side, it's multiplied on this side. No, rats. And then divide through by the 60, so k is the number 6. So if your period is 60 degrees, that means that you're going to get 6 full cycles in that 360 degree range, where typically you would have had just the one originally. Okay, so 6 times as many basically as there would have been. Other terms here, stretch vertically. So if you see something is stretched vertically, usually it'll say by a factor of, say 6. It means that what was originally looking like this is now going to be 6 times as tall, 6 times as low. Okay, so obviously stretch vertically is basically saying the amplitude is 6. Okay, so pretty straightforward stuff, provided we actually recognize what the terminology is saying. Compress horizontally, we can have compress vertically as well. Compress vertically would be a factor of 0.5 or 1/2 or something, so it's actually getting smaller, but again telling us the amplitude. Compress horizontally, again usually the wording will be by a factor of, means that what again used to look like this, let's see how well I can do here. If it's compressed horizontally by a factor of 3, it means that we're, not sure why I drew it that direction. Okay, so it's negative now. That's fine. It means essentially I'm going to have, can't do it this way. Sorry. I can do it that way, I just have to think more than I want to. So if this is my original sine curve, compressed horizontally by a factor of 3, means that I'm going to get 3 full curves in that same, there you go, beautiful, same 360 degree range. Same sort of thing, stretch horizontally by a factor of 1/2 implies that you're going to have only half of a cycle now in that same 360 degrees. So again, this is always basically referring to that regular 360 degrees. Factor of 3, there's going to be 3 of them. Factor of 1/2, there's going to be half of 1, and so on. I meant to switch this up here. It shouldn't be point, it should be if they give us a max or a min. And again, we've already sort of discussed that. what they're doing, what we're seeing there is information about the 3 and how it relates to the amplitude. Oh, I guess I kind of got ahead of myself there. Okay, so max min 45 degrees and 3 is telling us that the 45 is helping us determine how much shifting has occurred. The 3 helps us to, 45 helps establish shifting left and right, and the 3 helps establish shifting up and down with respect to, in company with the amplitude. So just sort of some terms you're going to see, the stretch vertically, stretch horizontally were the main ones. The period, of course, could mention the period specifically. It could say there are 3 full cycles, which is then giving us the K value specifically, and that's what we want. So just determining from what they give you, which one of those is more important. And I guess I'm going to stop there because the video is getting kind of long.